Hello guys, my name is Sajjad and I'm going to give you an introduction on GC-FID. This is a GC-FID instrument, and first thing you have to make sure is you have enough supply gas for this instrument. You need 3 gases for the instrument in order to work. First gas is hydrogen. Make sure the valve is open and the pressure is set onto 60 psi. Second gas is air, and make sure it's open when it's up to 60. And third gas is nitrogen. Make sure it's open and pressure is on 100. If the instrument was turned off, you can turn it on using this button over here. And after turning on the instrument using that button, you have to push this button to turn on the whole instrument. This is a startup procedure for the instrument, and this is a shutdown procedure for the instrument. So I'm going to go very quick through the startup procedure. As you can see, up to this point, air is 50 psi, hydrogen is 50, and nitrogen is 100 psi. So we have it. We're not worried about that. To unlock the keyboard, you have to come over here. If it is locked, you can unlock or lock the keyboard from here. Second thing you need to set on the instrument is the split ratio. So you will go to the split button and press enter. And make sure this dash line is on the split. And go to after that go to the flow and find MUP1F and set the flow on 30, press on enter. Then go to hydrogen, press 40 on enter. And then go to airflow 400 on enter. After doing that, you have to go to the column flow. Column flow, set the column flow on 0.8, velocity on 21, 0.8, 21, split ratio on 50, and column flow velocity on 21 and split ratio on 50. Okay. So column flow on 0.8, velocity on 21, and the split ratio on 50. There we go. So what is the split ratio? Let me show you very quick what is a split ratio. Okay, the split ratio shows the ratio of the flow that goes to the vent over the ratio over the flow that goes through the column. So that means if you are injecting 51. Show you here. So it's a split vent flow to the column flow. So because this is the structure of the injector, so that means not all of the sample goes through the column, but you are throwing away most of the sample away. You throw away most of the sample through the vent, and just a fraction of the sample goes to the column. So split ratio on 50 on this one. After that, go to the detector and turn on, push the on button, enter. And after that, go to the ignite and push on and enter. Wait for the star to come over here. That means the FID detector is turned on. So we will wait for it. So the column we are using in this instrument is a 30 meter fused silica column coated with polysiloxane in order to get a good separation for organic compounds. So organic compounds based on the interactions, molecule interactions to the stationary phase of this column, and based on the vapor pressure, dew point and things like that, they're going to be separated in this column. So let me check the rate again. So it takes a little bit time for the instrument to turn on the detector. Meanwhile, I will check pressures over here, which is fine. Okay. Alright. So we have to wait for the instrument to turn on. There we go, we have it. So you will see this little star over here. That means the instrument is turned on. Let me check the flows again. Okay, there we go. I was looking for this LED to turn on. I just wanted to check the flows again, so I have it here. That means all of the flows are okay. So whenever you see this LED turn on, that means the instrument is ready. Make sure the instrument is ready before starting the program. If you start the program, you're gonna have error before the instrument being ready. So now I am fine because the instrument is ready. I will start this program on the desktop. This program over here, the red one. I will go to the manual injection. You heard probably this beep. That means the instrument is connected to the program. I will push OK. I will go over here, instrument setup. You will see these pages over here: temperature, inlet pressure, FID, time programming, and trigger. So on the temperature, you will set up the maximum temperature for the instrument, and here you can set up the temperature programming, things like that. I will set this on 4 minutes. Okay. So as you can see here, I have a flat line up to 4 minutes. That means I'm doing isothermal analysis. If you want to do any programming, you have to put the rate of increasing the temperature over here. For example, I will put 10 degrees centigrade per minute, the maximum temperature 100, the wait time 1 minute. So you can see the ramp changed like that. So I'm gonna be 60 up to 4 minutes, as you can see here, and afterward I have a temperature ramping up to 100 to 8 minutes. So I will return it to the initial position because I'm gonna analyze acetone for you for this experiment. Okay, the second page in the pressures. So probably you have nothing to do over here except split ratio. As you can see here, we are throwing away 49. We are putting 1 in the column. And the column flow, we set it on the instrument, so there is nothing to be changed. FID, you can see the pressure of the gases, the flow of the gases over here, so you can adjust the parameters over here too. The runtime, that shows the time that the instrument is going to collect information. So the trigger, you have nothing to do with that. Time programming, have nothing to do with that. After you are done with this part, make sure you save all of this adjustment you have done up to this point as a method. The method is for you. So you will go to the file and you will go to the method, save as, and save it as whatever you want, the file name I mean. I will save it as A, for example, and there we go. Okay. Once you got the method saved, download the method. That would import all of the adjustment to the instrument, and instrument will use all of these adjustments that you have done. Just wait for that until you have this prompt that says the method has been downloaded successfully. Okay, and you can go and push this blue arrow over here, and make sure the method is over here is right. Data pass is the pass that you're saving the information after analysis. So make sure you're putting the right pass over here. You will start it. You will see this. You will see here, instrument is equilibrating the parameters that you have done. You have to wait for that for almost, I would say, 4 or 5 minutes to equilibrate. See, it's equilibrating method. So you have to wait for the prompt of the instrument that says it's gonna start data acquisition. Okay, so we have data acquisition here. If I push yes, that means I'm gonna start data acquisition, but I don't want to do that because I didn't inject anything to the instrument. So make sure grab a clean syringe for the injection, and this part over here on the instrument is the injector, and you have to inject through this hole. After cleaning the syringe, you need to get some sample. First, rinse the syringe a couple of times, make sure it's not dirty and it is rinsed with your sample. For the liquid samples, almost 0.2 microliter is enough. So take the sample. For the injection, you have to push the syringe all the way down to the injector, and then push the plunger and take out the syringe immediately. So I will show you how to do that. It's like this. Push the syringe all the way, inject, take it out. And we are done with the injection. We will start data acquisition on the instrument by pushing yes button on that prompt. So you can see here in the started data acquisition, you have to wait for the peak to come out, and after that I'm going to show you how to process the information, how to extract those information from the computer. About the injection, I want to tell you, meanwhile, when we have time until the peak is going to come out, the injection should be on just one step, and it should be very quick. Otherwise, you're gonna see some humps on your peak, and the peak shape is gonna be very bad. So be careful about the injection and make sure you're not damaging the plunger. As you can see here, people before damaged this plunger by pushing hard on the plunger and bending this stainless steel. Very fast and careful injection is crucial for getting a very good peak shape for the GC-FID instrument. We need hydrogen for this instrument and air, because technically we are burning samples in the detector to producing ions, and then by analyzing ions we can figure out what was the concentrations of the samples. So hydrogen and air is necessary for this instrument. And you can see here on the instrument the runtime and temperature of the column, as you can see here. So I think we're gonna expect some peaks by now, probably because the acetone is not pure. I'm expecting more than 2 peaks, so probably 2 or more. That means the acetone is not pure. So there we go, the first peak came out. And second peak. Okay, because we don't have time, I don't want to make this video longer, I'm gonna stop the data acquisition and go through the process of data collection. So I'm gonna stop it. Okay, so there's 2 ways to extract the information. First, right click on the page that you have data acquisition and go to utilities, copy to clipboard, and then paste the information to the PowerPoint and do the adjustments. Second way, you can go to the first page that I showed you before, go to the file, open offline, and open the file, open data, go and find your data that you have collected. My data is located over here, so it's this one. This is one of the informations, one of the peaks I got. So after pulling up this page, you will go to reports, go to view and percent area, and you have this page that says all of the retention times of the peaks, area, percent area, height, whatever you need. So you can print this page, attach it to your report, whatever, or save it as a PDF and use it. But so I told you two ways to extract the information from this instrument. First was right click on this page that you're running the sample, and go to utilities, copy to clipboard, and paste to the PowerPoint, do the adjustment, or go to this page and file and whatever. So, and for the shutdown process, it's very easy. I don't want to go through that. It's very easy. You have to just follow this instruction to turn off the instrument. Make sure you are going through the shutdown process before leaving the lab and ending your experiment. Clean the syringe afterward, and you're done with the experiment, and you're done with the instrument. So I hope this video was helpful for you, and have a good experiment.